there's two life insurance policies that are being sold, and they're both the same policy to each person. Okay, so it's one type of policy being sold to two people. If they die, there's a benefit of $10,000 that's going to be given out. Okay, and then the policies cost $1,000 each. So one person pays $1,000, and they get $10,000 when they die, according to this policy. Okay, then the policies expire at the end of the 10th year. So if they make it 10 years, nobody dies, they don't get the $10,000. So the probability that only the wife survives 10 years is 0.05. So the probability, here, let's put that in symbols. The probability that the wife survives, will let W be the event that the wife survives, and that means the husband dies, so the husband does not survive. The complement, the opposite, is 0.05. And the probability that only the husband will survive is at least 10 years, 0.005. So the probability that the husband survives and the wife dies, so the complement of the wife being alive, is 0.005, a little bit, 10 times less. And the probability that both of them will survive 10 years, so the probability that the husband survives and the wife survives, no complements there because nobody dies. The probability that both of them will survive 10 years is 0.97. I don't know if we use all this information, but we translated it into those symbols that we've learned in our statistics class. We're supposed to calculate the expected excess of premiums over claims given that the husband survives at least 10 years. But when they say expected excess of premiums over claims, they mean that take your premium, you get $1,000 per person, and there's two policies, so you got $2,000, and you want to subtract that by the expected value of the payout to these people, right? It's not a guarantee that either of them will die. It's not even likely that both of them will die. But we want to calculate the expected value of this policy that the insurance company will have to pay out, because we got to subtract that from our premiums that we're getting. The insurance company gets $2,000, but they want to subtract that by a weighted value of how much they could potentially give out. We're going to weight it by these probabilities. Okay, so the expected value part, we're going to use those probabilities off to the side. We're given that the husband survives at least 10 years. So if the husband survives, then there's two options for the wife. The wife lives or the wife dies, right? Let's see, so the expected value, we're going to pay out $10,000 if the wife dies, right? So that's the probability that the wife dies given that the husband survives. And that's a probability we don't quite have yet. And then we also, let's see, the other option would be, we need to subtract out 10,000. Well, actually, the other option, this is the wife dies. If the wife lives, the insurance company doesn't have to pay out a death benefit, right? So those are our two possible outcomes if we're told that the husband survives. The wife could die, in which case the insurance company loses $10,000. We're going to weight that with the probability that the wife dies given that the husband survives. And then the other option is that the wife survives, in which case the insurance company doesn't pay out that death benefit. So zero. We subtract out $0 for that option. So this is the real crux of the problem. We got to find out the probability that the wife dies given that the husband survives. We can use that conditional probability formula we studied in the course. We got $10,000. We're multiplying that by the probability that the wife dies and the husband survives. And then you divide that by the probability that the husband survives. Let's see. Okay, man, so I have more room. So we have this. We have the probability that the wife dies and the husband survives. That's right here. Doesn't matter the order, right? If you say Jack and Jill, that's the same thing as Jill and Jack. They're both the same event. But this one we don't have, but we can calculate real quickly. The probability that the husband survives, well, there's two outcomes. The husband survives and the wife survives. The husband survives and the wife dies. And we have both of those smaller probabilities. The probability that the husband and the wife both survive, according to this problem, is 0.97. probability the husband survives and the wife dies is 0.005. So the probability the husband survives, regardless of the status of the wife, is 0.975. Oh, now we finally have everything to finish out this equation. We got $2,000. That's how much. That's the premiums. That's how much the insurance company collects on these people. The death benefit is $10,000, but that's not a certainty. We have to multiply it because it's an expected value. We have to multiply it by the probability that we pay out that $10,000 benefit. And that probability depends on it's given that the husband has survived, so we need this conditional probability formula. The wife dies and the husband survives. Wife dies and the husband, that's 0.005. The probability that the husband survives, we just calculated, is 0.975. So if you plug this through your calculator, that'll get you to the final answer. Let's do the fraction first. 0.005 divided by 0.975. Multiply that to the $10,000 death benefit, and then subtract that out of the premiums. So the expected excess premiums over claims is $1,948.72 when we round.